Check out the micron ratings on those cartridges. What you're reading is the sieve size, the barrier size of those filter cartridges. What's the smallest number that's on there?
Half.
Right, half micron, 0.5 micron. And what cartridge was that on?
The Flow Plus.
The Flow Plus. Outstanding. Next one up. What was the next one?
B1.
Okay, Chlor Plus. Very good. Chlor Plus is 1 micron rating. And then finally?
10.
10 microns. Man, you're paying attention. I like that.
Yeah, wow.
10 microns. So with that being the case, if I have a cyst that is around 1 micron in size, which one of those cartridges can you depend on to take a cyst out of the water?
0.5.
Right. It's that simple. And I know this seems like really rudimentary, right? Like, okay, this isn't, what are we talking about here? But that's how simple it is, fellas, is that all you're trying to do is, depending upon what the contaminant is, create a filter that takes that out of the water. 0.5 microns. That Flow Plus cartridge is rated for cyst removal, and I think it says that it's it can be part of a system rated for cyst removal right on the label.
So none of these would filter out a virus, though.
No.
Yeah. So it would it would have already been filtered out by the time it got to your house and water supply. Should have been.
Should have been. Depending upon where the water's from. What's your name?
Ryan.
Ryan. It's a perfect question, because depending upon where the water's from and how it's been treated when it gets to the house. Because the next thing we want to talk about is, where's the water coming from as its supply source? Okay. So the next thing to your point, Ryan, okay, it should have been treated by the time it gets to my house. Well, where's the water coming from? Is it coming from a municipal supply, or is it coming from a private well? We just recently, in the last 5 to 10 years, in the United States, transitioned from a country that most people were getting their water from private wells to most people in the United States now are getting their water from a municipal supply of some sort. Somebody is supplying your water to you. Just within the last 10 years or so, we crossed that 50% mark, okay?
What are we at right now? The breakdown between municipal and private?
It's been growing rapidly. Even in places, have any of you heard of a program called Rural Water? Okay, it's happening more out in places like Iowa and Nebraska, where cities understand, hey, I'm providing a service, I'm going to start piping my water out to those farms out there and then supplying their water for them as a service. And they call it the Rural Water Program. So the desire to treat and then provide water out to the consumer is growing rapidly. I believe it might even be more than 60% now. But here's the thing about those two supplies. Municipal water supplies are regulated by the government. So you have to get the water to your customer at a certain level. And there's minimums and maximum levels that you can have of contaminants in that water. Private wells don't have those restrictions, okay? You have to test the well to make sure it's safe. And in a lot of states, I believe that you have to have it, it's mandated, you have to have a test done every time you sell the property. But in between there, it's the Wild West. And hey, I'm a conservative, and I don't have a problem with that, right? It's your well, it's your water, buyer beware, right? It's your well, nobody's charging you for it, and that's good, but whatever comes out of that well is your problem, right? Municipal supplies are regulated, that they have to supply safe water to you. So you're right, Ryan. If it's coming from a city, they have to make sure that it's free of bacteria and viruses and cysts and things like that. As well as heavy metals. There's a lot of different things that are on that list of contaminants that they have to be concerned with. How do we keep, we've been talking about bacteria, we've been talking about a lot of this stuff, because we're sticking with surface water right now, and we're sticking with physical filtration. What do I use to filter those things out? At a municipal water supply, what are some of the things they're doing to treat the water? I suck the water out of Lake Michigan. What's the first thing I'm doing? I put it through a plant. I put it into a big storage container, a big pond, and I put some chemicals into it, make a lot of the stuff that's in it coagulate together and fall out of solution. So I put it in settling ponds. That takes care of a lot of stuff. And then I run it through a series of different filters to take out some of the other things that are going to be in the water. Before it goes out to the homeowners and the businesses and everything else that goes out there, what are we doing? We put in disinfectant agents. So what's the most common disinfectant agents that cities use?
Chlorine.
Chlorine. Real simple. Chlorine. Bleach. Sodium hypochlorite is the most commonly used. So it's essentially bleach that they're feeding into the water. Bleaches work great. It's been one of the things that's advanced civilization, right? I can keep the water clean, I can send it out to people, I can give them fresh running water, and it's not going to kill them. That's great. But dysentery, don't have to worry about cholera, you don't have to worry about all those things. I can provide fresh, clean, fresh water out to people. Thing is with chlorine is it's really super reactive. Okay? It isn't just going out and hunting and killing bugs. It isn't just knocking out bacteria. It's also reacting with the surfaces of the pipes that it's running through. It's also interacting with the rubber and all of the things that it comes in contact with. So because of that, it gets consumed pretty readily went through the plumbing system. It gets consumed quickly, keeping the water clean. And the thing that the municipality has to be concerned with is it has to dose enough into the water supply here so that by the time it gets all the way out to the end of the water line, it has to have a residual of chlorination that gets into that home too to keep that water safe all the way out at the end. So I have to put a lot, more and more as plumbing systems grow, I have to put a lot more chlorine into the water supply to keep it safe and keep a residual at the end. Is hypochlorite, is bleach good for you? No. And it's not, and at certain levels, I'm sure. In fact, bleach is a big thing they use in dairy cattle because how much milk a dairy cow makes is going to depend on how thirsty it is, right? More water it drinks, it's going to make more milk. So it just so happens that if you put a little chlorine in the water, yes, beneficially keeps the water safe for the cows to drink, but it also makes them more thirsty, so they drink more water. And that's all the science that goes into all of that. Chlorine is very reactive. High levels of chlorine put in the water. It is very common in places like Florida, Houston, warm water areas where you're getting water coming out of the ground that's above 70 degrees, sometimes 80 degrees when it's coming into the house. It's not unusual in places like Florida and the southern part of the United States where you could get free chlorine levels in the house that are 2 to 3 parts per million. The water's chlorinated at heavy levels to keep it safe and clean. Warmer water, bacterial growth happens more prevalently, so you tend to dose heavier with chlorination in those areas. And because it's offensive as a smell, and people don't like the taste of it, another thing that we need to do is be concerned with the disinfectants in the water and filtering that out as well. So now we're going to start talking about things like chemical filtration. How do we remove things that are part of the water? That chlorine that's in the water is part of the water. A physical filter, a mesh screen, isn't going to take that out because it's part of the solution. So the next thing I want to talk about is carbon filtration. So activated carbon has been around for a long time. And some of the things that are great about activated carbon is that it is capable of removing heavy metals. It is capable of taking bad tastes and odors out of the water, as well as doing removal of chlorine. Does anybody know? They're giving that chlorine the ability to work out longer and act longer in the water to do disinfection. Now, On the flip side, what it does is it makes the chlorine a little less reactive so that it lasts longer in the water. So what I'm going to do is I'm going to take, so hypochlorite, which is an HOCl